Say welcome everybody to the extra content in the data manipulation and management SQL 101 class for spring of 2025. This is additional topics. I am your instructor, Jeremy Bergman for Omaha Data Science Academy. And the two topics we'll cover today is if you take your skills, these skills that you learned in this class in SQL and how to store data and manipulate and management, what does this look like when you go into a business, particularly a large enterprise, like a place where I was saying off camera has literally thousands of data sources to manage and huge numbers of records and all sorts of different data types too. Perhaps it's some unstructured text, or it's semi-structured, like JSON files. You wouldn't know too much about those, but it's a format to be able to capture data in a different way than relational tables. There's some that are semi-structured, and how do we manage all of that data at that level? It is a huge task and undertaking, usually very large teams at big places, because the data is always changing. The business rules of the game are always changing. New data is always being added and discovered. And then being able to do things like defining your data with data dictionaries or having data governance to be able to consistently define your business entities and things like that and maintain them is just an ongoing task that's underappreciated. So that is what this lecture is all about. And then we'll do I'll go through this really quick as extra content. I've left it in Slack for you to dive into in more detail. And then we'll cover some tools that will help you with these processes. So class objectives, we'll do some terminology of enterprise data, how it flows through the organization. So there are two things are called ETL and ELT. So your ETL is extracting it from different sources or source systems, and then you transform the data in your second step, and then you load it into something like a relational database. This has probably been the most common over time. You'll very commonly hear that in a big organization. Now there are more flexible formats. Teaching in my data engineering classes, but now there's a lot of thought around extracting raw data from a system and then just storing it and then figuring out all those transformations later. And this can be beneficial because sometimes you don't know all the ways a data source might be used. And it gives you some flexibility into being able to define the different ways instead of transforming it previously and then having to go do that a bunch of times. We'll talk about data management versus administration, like I said in the first slide at the beginning. Data management is a huge task in an organization that takes big teams. It even takes the interaction between technical users and business users and business managers. It takes a team effort to manage and define data. We'll cover that and how that's different than just database administration. So managing that data that lives within inside databases. Do data governance and measuring data quality. So data governance is the rules that organizations use to define certain entities or create business rules. We saw that a little bit in case statements. So you could do something like, if the country is Europe, do this certain tax. Maybe they have a higher tax rate, and you could define it that way. That would be something that you do in data governance. Data governance would say, these are the rules and how you should define that tax for, maybe it's even different states or cities in the United States, and then making sure that's enforced. And then measuring data quality. So we worked with, cleaning data in our 5th class using SQL. This is a way to measure data quality across an organization and different data sources. You can help by putting some metrics to it, just to be able to make a little more sense of it, and see where the opportunities are at, instead of having to look through millions of rows of data, which can be impossible potentially for a single person to do. And data dictionary. So data dictionary is like a location of common terms that everybody in the organization uses. So a bunch of people aren't defining things a certain way. Everybody's on the same page as far as what the calculations are. That can be a huge effort itself within organizations, is just getting everybody on the same page and using the same calculations. Is even something straightforward like revenue can mean 2 very different things to 2 departments, and how they define like revenue or expenses or whatever it might be. So I dove into a little more detail of that. I just want to provide a high-level overview of the content, because you can look at these slides in more detail and ask me questions about it. Feel free to do that with this last class. So types of enterprise data. If these terms look familiar, transactional data and analytical data, we covered those in class. They're the 2 different types of, there are 2 types of enterprise data. That's where the majority of it is. So it either is transactional data, usually out of systems or business events, and analytical data transforms that transactional data for use in for analytical purposes like reporting and dashboard and so forth, usually in a data warehouse or a data model, like we covered in class 5 when we talked about database modeling. Master data is kind of like what ties everything together. So master data can be like lists of customers or lists of business locations. It can be list of products. But once you have thousands of data sets, master data is really that source that standardizes it across all of the different data sources. Because even within different systems, you may define things just a little bit differently, and reasonably so. The master data keeps a record of how you define it and kind of like what the standard is for the organization for like those common entities. So master data management is a huge piece of this. You can make your own little career out of doing master data management if that's something you really enjoy doing. It's a lot of understanding systems and business processes and what management looks like, and communicating to a whole lot of people and trying to nail down definitions. You could be employed to do just that at a big organization and have plenty of work to do, never-ending work to do. Okay. Data storage terminology, OLTP. We talked about that. These are all the different potential OLTP systems. You have CRMs, ERPs, or like your supply chain resource planning. You have e-commerce websites you get information from. SCM, legacy, even external systems. One thing I did in more than one of my jobs is get survey results from an outside survey vendor who'd create surveys for the company and do customer satisfaction and then send them to us. Potentially one data source you have to herd, and then pretty much anything else. Nothing in an organization is really off limits anymore. Like I said, even unstructured data or textual data or semi-structured data. So traditionally, in a traditional enterprise data warehouse environment, what you do is ETL. We talked about that, extracting, transform, and load the data. You put it in what's called an operational data store after you've cleaned it and you've done all of that to it. It goes into data warehouse where it's properly defined and stored over time. You may create little data marts, which are like little databases for areas of expertise. If you think about your schemas in your database, they could be, you could have one for marketing, you could have one for the sales team, you could have one for call center operations. You'd have a bunch of mini data marts for specific subjects, all tied together using that master data management that we talked about. Usually these are connected to BI tools or reports or dashboards, and that's how the users see that data that's turned into information in the enterprise data warehouse. They could imagine the massive effort that something like this not only take to maintain, but could build. So there's stats out there that most data warehouse projects fail. That's because they become massive efforts in an organization. I think it's good to keep it small projects, and then build on it incrementally. Okay. So how data flows, going a little bit deeper into ETL, the data storage and terminology kind of shows how data typically flows for analytical data in the organization. This just shows a lot of the same thing coming from other databases, applications, or third parties. Some of these are now coming from the web. Usually these are transformed and stored in a data warehouse. More and more, I talk about this in data engineering. So if you have like text data and log and semi-structured or unstructured, they're stored in the cloud in what's called a data lake. And then the data lake provides you a bunch of tools to be able to transform that into data that you can use for analytical purposes, and your data marts and your end user tools. So very similar view to the other one, just more detail about how different types of data flows and is turned into analytical information and how the users in a business are able to access it and see it. Okay. ETL versus ELT. I did talk about that in the second slide. This goes into a little more detail. You do ETL traditionally. That's your more traditional method, particularly loading it into relational databases. So relational databases are highly structured data sources in tabular format. Like we saw, you have all the rules for first normal form and relations, and creating those so that you can use a SQL programming language to bring it all together. And store the information too, so storing it in tables or deleting it or updating it and managing it. So that's why that's so popular, is that you extract it, you transform it the way you need to get it into a relational database, and then you load it into those tables. And this is just a lot of the repeat of the same. But it talks a little more about transformation stage and then loading it into your data warehouse and then for analytical purposes. Okay, data management versus DBA. What is data management? So data management is the discipline of organizing and maintaining data process to meet the ongoing information lifecycle needs, including creation, storage, processing, archiving, and data destruction. So I worked on a team in the enterprise that did data stewardship and data governance. And it was all about creating and enforcing rules around like data creation and deletion, and how information is stored and accessed by users, and then how it's processed and archived. So after a certain amount of time, when you take data offline and put it in secure storage. So they have their own, if a company's big enough, you could have your own team that does that type of work too. On the other hand, database administration is really like the physical management of the server itself, using that specialized software like a relational database. They do the technical aspects of the planning, installation, configuring, making sure it performs well, security, backup, and recovery. So database administrators are worth their weight in gold. Theirs is more about making the database efficient and safe and redundant, where data management is about how do we take all this data so it continues to make sense for the entire organization. Data management is much less of a technical role as it is a people role, and database administration is much more of a technical role than a people role. But both types of professionals communicate over all sorts of different teams. In the end, it's all data too, but DBAs are usually focused on transactional data and sometimes analytical data. Data management is not always just focused on analytical data. Sometimes they also have say of managing data within systems also, and such as like how people enter data into a system or how data is captured in a system, and then consistency across all the systems too. All right. So data governance and stewardship, I kind of dove into that there on the last slide, but data governance and stewardships, they're all about this type of data. How do you manage the data life cycle? So from loading it all the way to deletion of the analytical data, like when do you remove it? So data quality, the data models, how do you store it? How do you secure it? Things like metadata and data dictionaries, master data, and so forth. They are the control quality. Really, data governance is a quality control discipline. They're kind of like the police, the data police, or the enforcers in the organization. Whereas the data steward is more about working with the business end to define data and that processes are followed, and make recommendations to the data governance process and how to continue to update and maintain data based on changing needs. Oftentimes a data steward, they'll put together a data steward team in an organization who is like an expert in a domain. Maybe it's someone in marketing who really knows all the marketing data. There'll be a representative as a data steward from their team to have a say how marketing data is used in the organization. Okay. Measuring data quality. So we've seen in lecture 5, oftentimes data is not perfect, and there's some things that you have to do to fix it for analytical purposes. And if these terms look familiar, it's because we covered those, like uniqueness, completeness, consistency, accuracy, validity, and timeliness. Often, like a data governance team will do data quality assessments, make sure the data is as good as it needs to be for analysis in the organization. And they track quality metrics for numbers and known errors in data sets. So if you're analyzing a data, I even do this as part of my consulting engagements, is one of the very first things I do is just look at data quality. Like, how good is this data set? Does it have a lot of missing values? There are a lot of weird values in it, inconsistencies. Are there duplicate uniqueness? That's probably maybe the biggest one I'll look at. But does the data can I just make sense of the data? especially given like what that client's trying to do with it. And sometimes maybe the data doesn't exist or it's in such bad shape from the system that you have to make a recommendation to the client just to be able to do what they need to do. Most of the time you can make something out of it, at least, and you can give them that recommendation. But even on a small scale, measuring data quality is important. And usually if you're doing metrics, it's metrics related to these data quality dimensions, such as missing data, incomplete or redundant entries, and errors. So I just finished work with a client where I created them a data quality database for their data source. They're pulling it from a bunch of different maintenance systems. So once they put all that data together, they append new data to their running data set twice a year. And when they do, they're able to check out the quality of it as they're putting it together, so that if something doesn't look right, they can go back in the processor of the data before it becomes data that everybody is using and making errors in decisions off of it. So get big or small, it's important. But on the large scale, it's usually metrics, because it's impossible to review thousands of data sets per day and the data that it's generating. Okay. So you can do data quality using Python. There's some libraries that you can use. I haven't used this one in a long time, but it's Python data quality and control. PyDQC. Actually generate a little report on your data set. So what it does, you read in the data, it infers the data types of those columns that are in the data set. It does some computations here, summarizes the data, and you can even compare it to a previous version too to look for changes. Then it outputs data quality reports. Okay. So it can be done in Python. I've used that library before for clients. That's why I mentioned it. Data dictionary. A data dictionary is kind of like the go-to source for business rules that are created in an organization. So we did some of this and called it business rules when we created these calculations in views. Now that can be really hard for a big organization to even know where to start or look for a certain rule. If you have thousands of data sets and hundreds of views. So in that case, a data dictionary comes in handy because it lists things like the source name, like where did that data come from, or what system, what table is it stored in, what columns from that source. So it's source to destination in your relational database. And then what transformation occurred. So oftentimes there's like a cleansing transformation where you start defining business rules. So maybe you call marital status single as S, married as M, divorce is D, widowed as W. So it's hugely important when you talk about people in a big organization using the same data in the same context. So the context in which data is generated in an enterprise is also really important. So understanding what system and how it was generated by a user, and what the significance of that generation is, or how it got into analytical data. And so the context and the transformations in business rules are huge to keep everyone on the excuse me, one, to keep everyone on the same page, and two, have consistent definitions everyone can use. Okay. So that's all about, need one more drink. That's all of that. Went over it really fast. Just want to give everyone a heads up into what it looks like. I do have one more lecture here on tools that you can use. Generally enterprise tools. You would see Talend is an enterprise open source enterprise tool. Might see things like Informatica or Snowflake is a big one for managing huge amounts of enterprise data and turning that into analytical data. Of course, you can use good old trusty Python on just about anything. You can also do this in the cloud. We'll talk about a different type of database just a little bit. Instead of relational database, relational SQL database, we'll do NoSQL database. Okay. So I'm going to cover this quickly. Just to get you familiar with some of the tools and what you may see in an organization, or how you may use some of these things on your within your job or whatever you are doing with data next. Okay. All right. So we're familiar with ETL and workflow tools. So oftentimes, instead of processes that you look at with code, now some of these tools allow you to see those visually, like Talend. One tool that contemporary analysis is often used for data science project is called Dataiku. It's really like creating workflows for data science projects. And what you can do with it is do the transformations you need to build predictive models or AI or machine learning models. It's more of what I'm going to end up covering it in much more detail in my data engineering classes. But there's always trusty Python there too. Cloud tools and storage that helps you manage all of this information now. I teach that in cloud engineering class, which is different than the data engineering class. I also have a cloud engineering class. So how do you engineer different types of data in the cloud, specifically looking at Microsoft Azure to do that, and those different types of relational databases. And don't forget to do your class or finish class project too. Okay, overview. If you're an engineer or even a data analyst, it's important to know all the tools that you have available. One of my favorite sayings is, if all you have is a hammer, then everything looks like a nail. So you're using that tool, and maybe it's not the most efficient way of doing it. It works, but maybe potentially there are better engineering tools that you could use for certain types of data or use cases and their analytics. So knowing what the latest tools are and some of the most popular tools among bigger companies. If you're looking for ETL jobs or engineering jobs, I would highly recommend just going out to a LinkedIn and just type in data engineering jobs and looking at their job descriptions, seeing what type of technologies they use, and then learning about it, or even potentially getting certificates about it with it and doing a project to show you've used this and you know the technologies and you've actually applied it to a project and be able to talk to it, which is what we do with our class project. And then just being comfortable finding and reading documentation. More and more, I am going to Claude to have me do that instead of reading through technical documentation that takes me a long time to figure out. But it can still be useful for details, or if AIs not as accurate or detailed as you'd like. Okay. So extract, transform, and load. We've already talked about this. I do have some examples here. So example of extracting is pulling customer data from CRM, sales data from a point of sale system, or inventory levels from an ERP. Transforming data can be standardizing date formats. We're familiar with that. Removing data duplicates, and even aggregating transactions, so summarizing data the way you need for your analysis. And then loading a data loading data from a system into like a target data warehouse for analysis and reporting. So an example would be populating a data warehouse or updating business intelligence dashboards through something like Tableau, like you took in the last class. So you're loading data into a source that allows it to update and change that. The transformed is what turned it into information, and loading it is what the business users can then use. Okay. So ETL using Python, mentioned that a few times. You can use Python to create data pipelines and transformations that you need for data to turn it into whatever you need for analytical purposes. So you can use Python to extract data from systems. There are lots of connectors and libraries to do that. You could use a library like Pandas if you haven't taken Python yet. It's a language in Python that you can load data into a tabular structure like you do with relational tables, and then be able to do lots of different operations and manipulations to it, then ultimately load it into a database or whatever data source that you're doing, even a data lake. Why is it popular? It's really common for data scientists and data engineers, easy for them to work together. There are lots of libraries that help with data or connections. It's very flexible. I heard data scientists for CAN call it a Swiss Army knife of data, which I agree. If you just need to create a process, a specific one, you can really create one on the fly, especially now that you have tools like Claude AI to be able to help generate code for you. These are also known as data pipelines because if you think of a process, it's like going one step, or going through one pipe and out in one pipe and out another, and then back into another pipe and out another, and so forth. And that's, as a data engineer, how you think of data. It's like those different transformations or steps in that pipeline that data's passing through. One of the challenges of Python, and I'll mention this, is on an enterprise level, if you have all of these different customized or flexible processes, they can become really hard to manage at scale. So if you change a rule in one, you may not even be able to tell if you've created 100 pieces of Python code. You may not even know where else you need to change that business rule. So at some point, that's where data governance and data stewardship comes in, and you formalize those type of processes and integrate them into a cloud platform, or you integrate them some different way, data warehouse environment, or standardized processes and so forth. So Python works great at a small scale. I just did that for a client. At a large scale, you need to be a little bit careful with creating all the pipelines, because the bigger and bigger they come, the more of a data management task it becomes also. Okay. If we talk about specific ETL tools, these are some of the tools that can make those processes easier. They're platforms that are specifically built for handling large data sources or many data sources or many different data pipelines. They also help with some things like data quality. You have data quality checks within Informatica, I know for sure. And data integration into other analytical sources or even back into other systems. There are many of these available today. There's really no end to it. I did this before Snowflake was created. If you Google Snowflake. So they call themselves American Cloud-Based Company, operates a platform that allows for data analysis and simultaneous access of data sets. That's probably understating it, really. Everything that they do, because they do master data management and data warehousing. And you can do like analytical data models. You can do analytical data models in it, and then like your machine learning and AI pipelines too. So just taking a look at this. Yeah, they tout that you can power your AI and apps and data on a foundation built for the future. So it's not necessarily the AI modeling itself, but you need good data to be able to create these analytical processes or models, or doing even analysis that data analyst would do. If you have bad data and a machine learning model, you're making bad predictions, it could have huge consequences. So being able to manage it this way with an enterprise tool is huge. Okay. Talon's just another type of ETL tool. I did it in the past because it's open source. You can download it. And this is what a type of pipeline would look like. You do a data integration, you deploy it to a repository, and then you can manage and present it in a dashboard. Data IQ, I was saying this is a tool that contemporary analysis is typically used. This touts itself as bringing data analysts, engineers, and scientists together. And it operationalizes machine learning. So it's a platform built for data scientists and engineers to collaborate and make it easier to build the type of applications that you would with machine learning or AI. So there are a bunch of steps to it. So often it's like creating a new project, getting a data source, transforming it. Visually, you're using Python, creating your model, deploying your model, then monitoring it. And I actually go through this entire process in my cloud data engineering class. It's like a machine learning ops deployment, like how from start to finish do you take data and create a machine learning model and deploy it and manage it and maintain it? Because even these models, anything with data, it's just never really done. Afterwards, you need to make sure that data remains high quality, that the models are making good predictions. If you change business rules, you may have to update these models. So whether it's a model or analytical data, the processes of monitoring and maintenance never really end. Okay. So what is NoSQL? This is one of the last topics we have here. So NoSQL, May mentioned it very early on in the class, just briefly. It's a good, really simply put, it's not a relational database or not SQL. It's alternatives to them. Almost always built for like specific use cases or like semi-structured and potentially unstructured data. Usually they have very specific data science applications. So MongoDB is probably one of the most important. It's one of the biggest ones. It's a document store for transactions. I used this a little bit in my web engineering class or cloud engineering class. The MongoDB is intended for data structures. If you take in Python class, that are sent to the engineer in a dictionary type format, which is also what JSON format is. You have key values. So you'll have a key. You do have tables in it, but it's a little bit different. So in a dictionary, you have a key in the dictionary, and then you have a related value. Is how you work with that data type. And then you have some other things like column stores. They're kind of like relational tables, but you do column values instead of all the values in the columns instead of rows than a relational database. You also have various things that are very specific tools to help you process big data, and specialized data distributed databases for that. What else? And I'm forgetting a number of other ones, but on the next slide, you have a bunch of different types. So we talked about document databases. So key value pairs. So maybe you have state is a key, and for each one of these records, you have Nebraska or South Dakota or Texas and so forth. You're able to get, and this isn't just necessarily one or key value, it could be multiple key values in a dictionary. So you have graph DBs. These are mostly like social media connections. If you think of yourself as one of these nodes, and then like all of your friends, and then all of your friends' friends, you can think about how big that graph gets. Facebook uses something similar for their web API to be able to get user information and relationships between people. It's very specialized data structure made for it, and very different than a relational database. Probably the one that's closest is like column family. Sometimes there'll be missing values and it won't have it in there, or you have some combined values. It's meant to be semi-structured and table-like. It can be a really flexible type of data structure to hold data in before you load it into a relational table. I cover that more in an engineering class. And documents. So document store, it can store links and associations to different types of files and different types of data sources. Kind of like your linked list in programming, all of your associated data sources. This can be good for being able to look up data sources, or being able to just reference data sources and use them. And if you have a wide mix or variety of data sources that aren't just text, maybe you have a relational table and maybe you have an image here. So it's like when you have a lot of mixed data. All right, so if you wanted, there's a NoSQL demo. And then why is cloud computing so important? So I feel like I'm selling my engineering class here a little bit, but it's really about all data management and processing at scale. That's what I tell my students. So it's a data engineering class is about building efficient pipelines and systems for handling and managing data. And then the cloud engineering is like specific Microsoft tools and cloud and how you would implement those type of solutions in an organization. That's what the discipline of data engineering is all about. But managing at scale and being flexibility and all the things that we talked about enterprise data. Your database comparisons, I have an AWS, Azure, and Google Cloud platform. They all really have similar technologies in the stacks. AWS is known for their robustness. Azure for their enterprise value and integrations. So highly integrated with companies that are already using a lot of Microsoft products. And Google has been traditionally known for their analytical platforms in like computer vision and AI and data processing and so forth, if you think about Google search engine. Some comparison between the technologies in Google Cloud and what it has to offer. Has a number of technologies that do different functions for different purposes. And then I have an exercise of how you'd move a MySQL database like we're using in class to Google Cloud Platform. All right. A little bit longer than I took, or I thought I would take, but still coming in under an hour. But those are kind of the things, everything in this class or in this lecture is things that you could expect in the enterprise when you're using data. So not necessarily directly related. It's not directly related to SQL. It's just why I don't have them as regular lectures in the class anymore, but good things to know if you're a data analyst going into an organization and how data works and flows and processes and the different types of teams that you might see there, especially in large organizations, and what tools may be available to you as a data analyst or a data engineer if you choose that route. And a little bit of a preview into the data engineering classes I teach too. I don't know, it's not usually the most exciting thing to people, but it's a living. Some people really love it. I kind of meant to do analytics, but there's all that work has to be done to effectively do analytics, especially at a big organization. So I spent a lot of my time doing that too. And it's all right. It's just a lot of under the covers and spending time. You do have to communicate with people still. It's not entirely under the covers job. Understanding how to take data and turn it into information in particular, and having to work. You end up working with a lot of other technical people too. So if you enjoy working with a lot of other technical people, and structuring and storing and managing data and pipelines and building systems, data engineering may be for you. And it's a living. I made a living off of it. It's always something interesting new problem or process or business rule or something. All right, so that's it for the class. Just wanted to thank everyone too for being good students in the class. I have a card that I put in to Slack anytime you want to reach out to me. I do my own independent consulting, but I often work through Nate Watson Contemporary Analysis on some projects, especially now really starting to collaborate on Data Science Academy and potentially internships for anybody who would like to get that under their belt, some data analyst type projects. Like we start managing some of those. So feel free to contact me. I can always forward things to Nate, or for internships, feel free to reach out to Nate directly and then mention me, and he'd help you work through actual professional projects. Happy to do that. All right, I'll go ahead and stop film. Cut. 3, 2, 1. End.